Merry Pi Day. So this is question 3. So these are A-level maths year 2. So maybe you could do this if you're in year 1, if you understand radians. But let's have a go at this question. So the functions f of x and g of x are defined. F of x is equal to negative 2 cos x. G of x is equal to sine of x plus pi over 2 in bracket plus 3. So we've got some graph transformations to our trig functions there, where x is measured in radians. So that's crucial. Solve the equation f of x equals g of x, where x is between 0 and 2 pi radians. So let's have a go. So we have these functions f of x and g of x. So I think because we're solving f of x equal to g of x, so the intersections of our graphs will show us the solutions. So what I'm going to do is I'm going to draw both of them on the same axes, and then we're going to use that. So I'm going to draw a set of axes, and I'm going to go from 0 to 2 pi. So I'm going to include some crucial ones. So I'm going to have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So I'll do a rough sketch. So negative 2 cos x. So that is, so f of x is negative 2 cos x. So if you think about graph transformations, so that's negative 2 times what cos x would be. So cos x normally starts at 1, comes down through pi over 2, and then you get a full cycle like this. So what we're going to do is we're actually going to multiply everything by negative 2. So it's actually going to start down here at negative 2, going to come up, it's going to have a maximum here, going to come down here. So it's going to begin at negative 2. It's going to have a peak up here at 2, and you can see that it's going to have this equal to 2 here. So that's one full time period of cos. So we've done the graph transformation multiplying it by negative 2, so that affects the y. So we've got 2 transformations to g of x. So I'm going to do that in a different colour. So g of x is equal to sine of x plus pi over 2 plus 3. So the pi over 2 in the bracket, so what this is going to do, it's going to shift negative pi over 2 as a translation, and the plus 3 on the end is going to move it up 3. So effectively what I want to do is I'm going to take sine x, y equals sine x, and apply this transformation. So sine x normally begins at 0. So if I'm going to move it this way, pi over 2, so it's actually it would actually begin over here at negative pi over 2. So sine x, if we translate it negative pi over 2 and move it up by 3, so originally, so if we just moved it pi over 2, it would get to 1 here. So we're actually going to move it up. So it's actually going to cross our y-axis up here at 4 somewhere. So then it would come down. So if we get to 3 at pi over 2, we'd actually get to 2 at pi. So it's going to meet here, and then it's going to come up, so 3 pi over 2, and we're going to finish. So it looks a bit like cos moved up. And so you can see here that sine x and cos x, the only time they actually go near each other is actually at x equals pi. So this is where they meet. So funnily enough, very strange, the solution is pi. Happy Pi Day. Congratulations if you got pi for that answer. By the way, we're probably getting the idea how these work here. So don't just guess it's pi. You have to work it through. But yeah, if you feel good, why don't you have a go at question 4.